This is still familiar because it's still the same stuff that we have done before. It's just got a sine or a cos in it. Okay, and whether it's a sine or a cos, it doesn't change these A, B, C, D at all. Okay, so we have to remember that A is for the amplitude, and I'm just going to put A in absolute value, meaning it's like the positive version of it. We're not talking about the negative because the negative means it's a reflection. But what A is, so just A alone, that is the vertical stretch, right? Because it affects the amplitude. It's making your picture taller. Okay, so if A was negative, so if A is less than 0, or you can put if A is negative, that is our vertical stretch, or sorry, that is our reflection. Okay. On X axis. Okay, I shouldn't have wrote so big. I'm going to run out of room here. We need to remember, we talked about this the other day. This affects the period length, right? So our period length is 2 pi over whatever B is, because B is our horizontal stretch, meaning it's compressing it or shrinking it, right? So this value is showing our horizontal stretch. And I know it's called a stretch even though it's shrinking it. It would be a compression, okay? And so this whole thing, 2 pi over b, this is your period length. Okay, so this works the same way as it did before. This is a movement on the horizontal axis, right? And so if it's a negative, it's moving the opposite. It's moving right. And if it's positive, it's moving left. Okay. So C is positive, you move left. C is negative, move right. And it's called a horizontal translation. Okay, and then our last one is still the same as it was before. It's a vertical up and down. So if D is positive, you're moving up. If D is negative, you're moving down. So a vertical translation. If D is positive, then move up. D is negative, move down. Okay, so example 1 on page 240 says sketch the graph of the function y equals sine, and then we have in brackets x minus 30 degrees plus 3. Okay, so since we're in degrees, our baseline is going to be in degrees and not radians or pi's. Okay, so first let's just look at this equation and figure out what we know from it. Okay, so do we know an amp? 1. Yeah, so it's really not stretching at all. Is there a negative in the front for a reflection? So no reflection? No. Okay, what about this guy here? What's that? Okay, so that's a horizontal translation of positive 30 degrees, right? So that means we're going to the right 30. Okay, what about the period length? The period length would show something right between the sign and the bracket. So what is our B value there if there's nothing? It would be 1, right? So our period length is 2 pi over 1, which is just 2 pi. Okay, so there's really no horizontal compression, stretch, whatever that goes on there, right? And then what about this guy here? Yeah, so he's a vertical translation, a positive 3. So you're going up 3. Okay? Okay, so now we have it all spelt out what to do. This one says sketch the graph, and then we'll find the domain and range and use the language of transformations to compare your graph. Okay, so technically we did C first because we said what was happening. What's up? Okay, so since we did C, we use the language, we know what's going to happen. Then let's draw the picture and then we'll be able to see the domain and range from the picture. Okay, so you guys are going to have to remind me what we're doing because I'll erase it. And here we go. So we know that our period length was 2 pi, right? But we're talking in degrees, so what is that? 2 pi is equal to a full rotation around, so 360 degrees. Okay, so we'll say that's 360 degrees. Okay, and then halfway between is 180, this is 270, this is 90. So they're going up by 90 each time, right? So this is where we can do two things. We can start by drawing the original and then shift and then up. Okay, so I think we'll start with, since it's sine, the original, if we were drawing y equals sine x, the original, we would go up to 1, down to -1 for the amplitude, right? So we'd start at 0, 0, and we'd go up, back, down, and back. Okay, so up, down, or back, down, and back. Okay, so that's roughly what our normal typical picture looks like. Okay, but now we have to remember that, I'm going to switch the pen colors, we have to remember that we said we were going 30 degrees to the right and 3 up. Okay, so 30 degrees to the right means, what did I say, there was 90 in between? So this is like 30, 60, oh, oh boy, hold on. I'll fix that. So this is 90. So then this would be 30, 60, 90, 30, 60, 90, right? So then this one will have 2 ticks. So I'm just marking extra ticks in there so that we can see how we're moving 30 degrees, right? So since we have to move 30 degrees to the right, this would be 30 more. Then this one would be over 1. This one would be over 1. And, oh, did I mark him on there? Sorry, my bad. Oh boy. So this guy's here, so he has to move over 1. He's moving over 1. He's moving over 1, and this guy's moving over 1. So everybody moved over 1. That's all I did so far. Okay. And by 1, I mean 30 degrees, right? I moved. The 0, 0, 1 is right there. Yeah, because he moved over. Okay, and then everybody has to move up 3 also. Okay, so if this was at 0, this guy has to now be at 1, 2, 3. Okay, and this one was at 1, so he has to be at 1, 2, 3, 4, right? And this guy was at 0, so he's at 3. And this guy was at -1, so he would be at 2. I gotta make sure I keep it lined up. And then this guy was at 0, so he would be at 3. So your picture would look like, whoop, mine's kind of ugly, but Okay, so example 3 is page 241. This equation looks a little bit different just because we have a 2 in front of our x. Okay, so we probably need to deal with that right off the bat. And before, when we had something in front of the x, we had to divide out by it, right? So we are going to divide by this 2. Okay, so the 2 is going to come out to the outside, and 2 divided by 2 just leaves us with x. And we had a 2 here, and we divided by 2. So we're just going to be left with a pi over 3 in the bracket, because these two will cancel. And then we still have the plus 2 afterwards. Okay, so now he's in his proper spot because he's the B of this question. Okay, so if I asked you what's the amplitude, it's 3. If I asked you what the period length is, it would be 2 pi over 2, because that's what our B is, which makes our period length just pi, because the 2's can cancel. Okay. We have a horizontal translation of what? Okay, positive translation of pi over 3. So that means we're going to move to the right. Okay, and then our vertical translation is, yeah, it was negative, and now he's positive, so he's moving its opposite. Perfect. So vertical translation is positive 2, so we're going to move up 2. Okay, so I moved to a blank page, and we're going to draw this picture. Okay, so our period length was what? Okay, 2 pi over 2, which is pi. So then that means these are in quarters right now. Okay, so 1/4, 2/4 is a half, 3/4, and then a pi. And then we need to figure out, because we're going to move a third, right? So we can either just move a third back, like just separate these into 3 pieces, like that, and then you would just move. Oops, I might have put too many in there because it should have been 1, 2, and then 3. Hold on. Uh, 1, 2, 3, 4. Okay, so, whoop, was this a sine graph? Okay, and our amp is 3, and then we're